Hi everyone, welcome to my Core 3 OCR June 2012 paper. We're going to look at question 8. Now if you look at part I, it says express 3 sine theta plus 4 cos theta in the form r sine theta plus alpha, where r is greater than 0 and alpha is between 0 degrees and 90 degrees. Now what you want to do for this question is straight away look in your formula book and try and find something that corresponds to the double angle formula for sine. So if we look at the formula for sine A plus B, we get, I'll write this out, so r sine theta plus alpha is our A and B. We get r, which we can leave outside a big bracket because that isn't going to change anything, it's just a multiplier. And we get sine A, which is sine theta, cos alpha plus cos theta sine alpha. So all we've done there is equated our formula here with the double angle formula in your formula book. Now the reason that we've done that is because we've got 3 sine theta plus cos 4 theta, and we need to see what corresponds if we look at these trig things here. So what we're going to do is write 3 sine theta plus 4 cos theta here, and think about how the equations equate. If you imagine timesing out this big bracket, all it's going to do is make it so we've got r here and r here. Now I've highlighted what is common in both sides of the equation, sine theta and cos theta. Now we can do what's called comparing coefficients. It's basically spot the difference in the equation. So next to sine theta on the left hand side we've got 3, and on the right hand side we've got r cos alpha. So that means that 3 equals r cos alpha. Similar thing for the cos theta, we know that 4 is the same as r sine alpha. So 4 equals r sine alpha. Now there are 2 simultaneous equations that must be solved at the same time, and we've got little tricks to do this. The first trick is to think about r sine alpha divided by r cos alpha. Now we know that the r's are going to cancel, and we know that sine over cos is tan. So we get tan alpha. And we also know that sine alpha was 4 and r cos alpha was 3. So that means that tan alpha equals 4 over 3, which we can solve by doing tan to the minus 1 of 4/3. And if you put that into your calculator, you're going to get 53.13 degrees. So we have our angle. The trick for finding r is by thinking about squaring this whole equation. So we get 3 squared, which is 9, equals r squared cos squared alpha. And squaring the other equation, we get 16 equals r squared sine squared alpha. Now we know that cos squared alpha plus sine squared alpha is 1, and actually if we add these 2 equations together, we get that 9 plus 16 equals r squared cos squared alpha plus r squared sine squared alpha. We can factorize out the r squared, And this big bracket is obviously going to be equal to 1. So to find r, we square root 25, and we get r is 5, which means the answer to your question is 5 sine theta plus 53.13 degrees. Okay, so that's part 1 then. Part 2 starts off with the word hence. That means that you're going to have to use what we found out in part 1 to help you with part 2. So part A of part 2 says solve the equation 3 sine theta plus 4 cos theta plus 1 equals 0. So look at what we've already done in the previous question. We found out that 3 sine theta plus 4 cos theta is the same as 5 sine theta plus 53.13 degrees. So we're going to swap 3 sine theta plus 4 cos theta for 5 sine theta plus 53.13. And then we've got the plus 1 equals 0. This is what we have to try and solve. We take away 1, divide by 5, and we get that sine theta plus 53.13 equals minus a fifth. If you do sine to the minus 1 on your calculator, it will give you a value for theta plus 53.13 of minus 11. Let me just write this down. Minus 11.54 degrees. Now, this thing that I've circled is what we want to use to find any other angles that we need. The inequality that we are given says that we are looking for angles between minus 180 degrees and 180 degrees. If we're investigating this thing, we need to alter our limits by adding on 53.13 degrees to the 3 terms in the inequality. So, theta plus 53.13 is going to be between minus 126.87 and 233.13 degrees. Now, if we think about our sine graph, the first answer that we've got, minus 11.54 degrees, is somewhere around here. So that's the value. Now this is minus 90 degrees, minus 180 degrees. The answers that we want are hence going to be the one that we've just labelled and this one and possibly this one. We would also need to check this. Now using the graph, you think if this is minus 11.54, this angle is going to be minus 168.46, which is not in our range, so we don't use. This angle is going to be at 191.54, which we will use, and the final value from here is going to be 348.46, which we will not use. So we've got two answers for theta plus 53.13, minus 11.54, or 191.54. Obviously, we want to find theta, so you need to take away 53.13 from each of these answers here. Okay, and we get minus 64.7 degrees and 138.4 degrees, which is your final answer. In part B of the question, we are going to still follow on from the first part that we did, and we're going to have to use this expression again. Now if you notice, we've got our original expression, 3 sine theta plus 4 cos theta. We're going to substitute in our newfound expression. So minus 37 is less than or equal to 5k, which is going to bring our 5 up to front, sine theta plus 53.13 degrees plus c is less than or equal to 43. Now it's very important that we understand what's going on at this stage. We have now condensed things down to just one trigonometric function, sine. Now what we know about sine, it never raises above 1 and it never dips below minus 1. So the max value of this thing in green is 1. The min value of this thing in green is minus 1. Now if you think about what the inequalities are saying, the minimum value that this thing in the middle can possibly be is minus 37. So if we set the green box as minus 1, we're going to get minus 37 equals, because it's the minimum, minus 5k plus c. If we do the same for the maximum, we're at this end and we have 5k, because now for the maximum we're using 1 plus c equals 43. These are two very basic simultaneous equations. So we're going to write one below the other and solve with our GCSE methods. Okay, so we can erase that one. Adding the two equations to get 6 equals 2c, and hence c is 3. To get the value of k, we can use this top equation. Minus 37 equals minus 5k plus 3, which gives minus 40 equals minus 5k, aka 40 equals 5k, and hence k equals 8. So that is how you find the unknown values of the inequality. I know it's hard thinking what to do here. The most important thing to realise is about the trigonometric functions being bound between minus 1, sine and cosine in particular. I hope this has been helpful. Please like if it has done, and don't forget to subscribe to my channel. Any questions, feel free to ask in the comments.